Right now there is a good chance you have talked to something that isn't human, and it felt like it was. Stick with me because by the end of this video you're going to know something almost nobody talking about AI online actually explains. What's really running underneath your chatbot? Why it can't become the sci-fi AI you're picturing yet? And which 5 technologies being built right now might change that? Go back just a few years. Before ChatGPT existed, if you told someone a machine could hold a real conversation, joke with you, comfort you, explain quantum physics, and then help you write a birthday message, they would have said that it's just science fiction. Then it happened, and it happened almost overnight. So what changed? One phrase buried in a 2017 research paper from a small team at Google: attention is all you need. That paper introduced the Transformer, the architecture sitting inside ChatGPT, Gemini, Claude, and basically every AI system you have ever heard of.
Its big trick was letting a model look at every word in a sentence at once and weigh how much each word matters to every other word,
instead of reading left to right like a human would. That one shift is why AI suddenly feels less like autocomplete and more like something that understood you. But here's the part that nobody explains. The Transformer did not invent the AI brain. It's just the technique we found for training it faster. The actual brain, the neural network, is not new at all. It goes back to 1943, where a neuroscientist and a mathematician first modeled the neuron as a simple mathematical switch.
In 1958, Frank Rosenblatt built the perceptron, the first machine that could learn by adjusting its own internal weights.
By the 1980s, researchers had refined a technique called backpropagation, which lets these networks actually learn from their mistakes layer by layer. In 1989, Yan LeCun used that same technique to teach a network to read handwritten zip codes. None of that was recent. That's 20th century science. The Transformer in 2017 didn't create the neural network. It gave us a radically better way to interact with it and scale it up. It's the difference between inventing the engine and inventing an assembly line that lets you build a million of them, fast, in parallel. So why don't we have a real-life Terminator? For anyone who hasn't seen it, that's the movie where an army built AI called Skynet that becomes self-aware and decides humanity is a threat, then builds robot soldiers to wipe us out. Or why isn't there a robot walking around indistinguishable from humans? Like in Detroit Become Human, a video game where android workers look, talk, and eventually think so much like people that you genuinely can't tell them apart. It's not that intelligence like that is physically impossible. It's that the Transformer, for all its power, has a very expensive habit. Every time you double the length of the text it reads, the computing cost doesn't double, it roughly quadruples. That's why AI still struggles to hold a truly enormous memory or to keep learning in real time the way a human brain does.
Building something like Skynet on this architecture isn't a movie magic problem. It's a cost, speed, and physics problem.
The compute and the electricity bill would be almost unthinkable. Researchers are already working around this, quietly in labs most people will never read about. A new generation of architectures is coming, not to replace the neural network, but to find a smarter, cheaper way to run it than the Transformer. There are 5 of them worth knowing, and the last one on this list is a genuine full-circle plot twist in AI history. Released in 2025 by researchers at Google, DeepMind, KIST, and Mela, a normal transformer forces every single word through the exact same full stack of processing, like making every student sit through every class whether they need it or not. Mixture of recursions lets the model decide, word by word, how much thinking is actually required, reusing the same layers instead of building the new ones. Tests showed it could match a full-size Transformer's performance using roughly a third of the unique parameters. Based on something called a state space model, a decades-old idea borrowed from control engineering. the same field that gives us cruise control and thermostats. Unlike the Transformers' exploding cost,
Mamba's cost grows in a straight line as text gets longer, not exponentially.
that makes it a serious contender for AI that needs to remember huge amounts of information cheaply. Built by AI21 Labs, Jamba doesn't pick a side. It's a hybrid that interleaves transformer layers with Mamba layers, taking the strengths of both. The result? Roughly 3 times the throughput of comparable transformer-only models on long documents, while fitting on far less hardware. Built by researchers at MIT, modeled on the nervous system of a tiny worm called C. elegans, which gets by on just 302 neurons. Unlike a normal AI, which freezes the moment training ends, a liquid network keeps adjusting itself as new data comes in, using a fraction of the parameters a transformer would need for the same job. And here's the full circle moment I promised. Sepp Hochreiter co-invented a network called the xLSTM back in 1997. 20 years before the transformer even existed, and for the long time, it was the standard for AI that dealt with sequences and language. In 2024, Hochreiter came back and modernized his decades-old idea into xLSTM, and it's now competitive with transformers at a serious scale. The technology that transformers replaced might be the one that helps replace transformers. So will one of these models actually replace the transformer? Maybe not yet. L. Leon Jones, one of the actual co-authors of the original Transformer paper, put it simply: any successor has to be crushingly better, so obviously superior that the entire industry, with all its infrastructure built around transformers, has no choice but to switch. That hasn't happened yet. But somewhere in a lab right now, someone is chasing exactly that. And the next leap in AI, the one that might finally close the gap between a chatbot and something that feels genuinely, unsettlingly intelligent, probably won't come from making today's models bigger. It'll come from finding a better way to run a brain we have already had since 1943.